Hello everyone. Let us we start with Unit 2, Session 8 of Engineering Mechanics and Strength of Materials. The last class which we are discussing about principle of superposition. What is meant by principle of superposition? It states that the effect of several actions taking place simultaneously can be reproduced by adding the effect of each action separately. It means to say that there are number of forces acting on a member simultaneously can be arranged in a systematic way by adding each forces. So let's we discuss about problems. Yesterday we discussed the theory part of that, so the principle of superposition. So let us we start with numericals. I'll read out the questions. A brass bar having a cross-sectional area of 100 mm square is subjected to axial force. Find the total elongation of the bar. Take E as 1.5 into 10 to the power of 5 Newton per millimeter square. And the sketch is given. The bar having the cross-section area and the length and the forces acting, axial forces acting, which is given in the diagram. Let us start with the slide shows. This is the question. The bars are having a cross-sectional area of 100 mm square is subjected to axial force as shown in figure. Find the total elongation of the bar and modulus of elasticity. Young's modulus of elasticity is given as 1.5 into 10 to the power of 5 Newton per mm square. AB, BC, CD is the bar having the different cross sections. Whereas the bar AB is subjected to a tensile force of 15 kilonewton, which is given. See, this is the bar AB, which is subjected to a tensile force outward directions. The arrow symbol, it represents the tension 50 kilonewton. We are using the positive sign here. Similarly, the member CD is subjected to an 50 kilonewton tensile force. It is arrow showing outside. It means to say the tensile force. So what about the member BC? The force acting on the member BC, whether it is tension or it is subject to a compression. That is a question. We need to do some logic here. The same 50 kilonewton force should be acting in this direction. Totally here 80 kilonewton is given. It is compressing the member of BC. Right? 80 kilonewton. And this out of 80 kilonewton, 50 kilonewton is tensile force the member AB, right? 50 kilonewton is for what? Member AB. Okay. Then what about the member BC is subjected to? Let's see. 50 plus x is equal to 80. 50 plus x is equal to 80. Therefore, x is equal to 80 minus 50. Therefore, how much it is? 30 kilonewton. What type of force it is? Compression. See, this force is acting compressive force 30 kilonewton. 30 plus 50 how much? Here it is 80 kilonewton. Similarly, what is the member BC at the end C? The force acting, it is equal to compressive force. Again, it is a compressive force. It is equal to minus 10 plus x is equal to minus 40. Why the minus symbol? Here is the lesser force, here is the greater force. Always the greater force have the tendency to apply here. So 10 kilonewton is the positive sign we are taken as a tensile force. 40 kilonewton is obviously what type of force? It's a compressive force. It is subjected to the member BC, so we are using minus 40. So whatever the total force which is acting on this member is equal to minus 10 plus x is equal to minus 40, then x is equal to minus 30. Minus represents what it is? Minus 30 is what it is? Compressive force acting on the member BC. Okay, so what we need to find out here? Total elongation of the bar. What the elongation of member AB, and what's the elongation of member BC, and what's the elongation of member CD when it is subjected to the three different forces and having the cross sectional area is given as 100 mm square and the varying length is given. For member AB is 0.6 meter length, member BC is 1 meter length, and member CD is 1.2 meter length, right? Okay, so what is meant by elongation? Elongation. What is meant by elongation? Change in length, exactly. So member AB is subjected to 50 kilonewton tensile force. So what would be the elongation of member AB? If the member BC is subjected to a 30 kilonewton compressive force, what would be the elongation? And member CD is subjected to a 10 kilonewton tensile force. So we need to find out that is also what is called as elongation of member CD. Okay, so elongation is nothing but change in length. Elongation is nothing but change in length, which is given by the equation the PL by AE, where P is the force, L is the length of the bar, A is the cross sectional area, and E is the Young's modulus of elasticity. See here, delta L is the total elongation, which is equal to plus PL by AE. P1, L1 represent the member 1, that is AB. Okay, P1 is the force at the member AB, L1 is the length of the bar at AB. Okay, next minus P2 L2 divided by AE, because AE is common here. Cross sectional area is also same, and Young's modulus of elasticity is also same. Next, minus sign here represent the member BC is subject to a compressive force of minus 30 kilonewton. So that's why they are directly using the minus sign. Then P2 is substituted as positive sign 30. Okay, instead of minus 30, they are using the symbol here minus because of it is a compressive in nature. Next, P3L3 divided by AE is a member CD, P3 force, and L3 is the length of the member CD. Substitute all the data and find the total elongation of the bar. So P1, what is the value of P1? 50 kilonewton. 50 into 10 to the power of 3 kilonewton. 1 kilonewton is equal to 1000 Newton. 50 into 1000. 1000 is nothing but 10 to the power of 3. So 50 into 10 to the power of 3 into L1. It is 0.6 meter is given. We are using Newton and millimeter sign convention for all the units. Okay, Newton and millimeter. So that's why here it is at 50 into 10 to the power of 3 and 600 mm. Instead of 0.6 meter, we are writing it as 600 mm. Okay, divided by A 100 mm, 1000 mm square is how much? 1000 mm square into E is 1.5 into 10 to the power of 5 Newton per mm square minus P2 is 30 into 10 to the power of 3. So whereas P2 is compressive in nature, that's why already they have used sign negative sign here. So here you have to substitute as P2 is equal to 30 into 10 to the power of 3 into 1 meter length BC is equal to 1000 mm. Again the area of cross section is 1000 mm square, and Young's modulus of elasticity is how much? 1.5 into 10 to the power of 5 Newton per millimeter square plus yeah, they have done the mistake. Is a 10 into 10 to the power of 3 into 1.2 meter, that is 1200 mm, divided by 1000 mm square into 1.5 into 10 to the power of 5. Okay, so what is the ultimate result we got here? 0.2 minus 0.2 plus 0.008. So total elongation of the bar is 0.08 mm. So member A, B, C, D is subject to three different forces. The total elongation of the bar is how much? it elongate, it is get expanded, it doesn't get compressed. See positive sign here, 0.08 mm. Okay, so and what are the stresses in these bars are, stress is nothing but force by area, respective force divided by respective area, we will get the respective stresses in the bar. So what is the maximum stress here, 50 Newton per mm square, and what is minimum stress here, 10 Newton per mm square. Okay, understand? Next we move on to next topic here, lateral strain. Lateral strain, already we discussed about the longitudinal strain. The longitudinal strain is nothing but the change in length by original length. It means to say that longitudinal in the length of the member. For example, this is the pen, it taken as a member. So this dimension is longitudinal dimension, and this dimension is nothing but lateral dimension. Whenever the lateral symbol represent, it represent what? Diameter, thickness or breadth of that member. The longitudinal dimension represent length of the member. Okay, so longitudinal strain is nothing but change in length by original length. Lateral strain is nothing but change in diameter by original diameter, or change in breadth divided by original breadth, or change in thickness divided by original thickness. Depends on type of cross section area. If it is circular cross section, it is a change in diameter divided by original diameter. If it is a rectangular or square cross sections, cubical cross section, it may be a breadth or thickness will be considered for finding the lateral strain. Let's we discuss about this. See, this is the circular cross section. Apply a tensile force P, then it is going to expanded in longitudinal direction, and length of the member which is going to be increases. So then automatically what happens, the diameter of the bar decreases. The diameter of the bar decreases. Once the length increases, the diameter decreases. The longitudinal strain represents its length increasing in nature. Similarly, the diameter which is decreases, that shows the lateral strain. When tensile force acts, it extend axially and shrink laterally. That's what I said. So it expanded, the length which is going to be increases, extended axial direction, the direction of the force in which is acts when the tension force, and it shrinks. See, so this is the dotted line represents the original diameter of the section, and the straight line represents the after expansion, the what is the diameter. So it what happens, see here is a decrease in nature, the diameter. So already which I told you, longitudinal strain E longitudinal is equal to change in length delta L divided by original length L. Similarly, the lateral strain is equal to change in diameter divided by original diameter. Similarly, area of the section will also get changes and length of the get changes when we apply the same circular section compressive force. What happens? See, the diameter will going to increases, the length will going to be decreases. That is the effect when we apply same cross section, circular cross section to compressive force. Okay, when the compression it shorten axially ಅಂದ್ರೆ ಲೆಂತ್ ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಆದರೆ it will bulge in outward direction, so lateral direction, then what happens, the diameter will going to be increases. Okay, E longitudinal strain is equal to delta L by L, and E lateral strain is equal to delta phi by phi. So change in diameter divided by original diameter. Okay, similarly this is the cubical sections we have. E longitudinal delta L by L. See, E lateral is equal to change in diameter or original diameter. Again, E lateral is equal to change in breadth divided by original breadth, or E lateral is equal to under lateral strain. E lateral, I am saying that. So change in thickness by original thickness. Okay. The longitudinal strain defined as the ratio of change in length by original length. So similarly, the lateral strain is defined as the ratio of change in lateral dimension to the original dimension. Original dimension. Okay, this is about the lateral strain. This is about the lateral strain. Okay, next I need to discuss about the one more topic, which is Poisson's ratio. Which is Poisson's ratio. Okay, what is meant by Poisson's ratio? Why we need to find out? So there are certain relations we need to establish while finding the stresses or strains in the members. So what are those relations are called as elastic constants. Those relations are called as elastic constants. When the body is stressed and which is in elastic limit, the lateral dimension produces constant ratio with longitudinal dimensions. I mean to say that the ratio of lateral strain to a linear strain is constant when the body is stressed and which is in elastic limit. That ratio is called as Poisson's ratio. So what is meant by Poisson's ratio? It is the ratio of lateral strain to the linear strain. Lateral strains to the linear strain, and it is denoted by mu, and which is denoted by mu here. So or it can be called as 1 by m, 1 by small m. So it is denoted as, okay. The Poisson's ratio is nothing but what? Lateral strain to the longitudinal strain. Lateral is nothing but diameter, thickness or breadth. Longitudinal is nothing but axial directions or along the length of the member. What is the strain occurs? Lateral is nothing but along the breadth or thickness or diameter. What's this? Strain is going to be taking place when it is subject to stresses. Okay. See, here is a strain which is representing, and it's a sign conventions, and these are the materials we are having, like metals 0.33 and ceramic material 0.25 and polymers 0.45, and polymers are 0.45. Always the Poisson's ratio value is in between 0 to 0.5, even not 0. For example, as the material Poisson's ratio increases, the material density will going to be increases and densely packed. If the Poisson's ratio decreases, is nothing but it is density will going to be decreases as having some voids. Okay, as having some voids. Okay, next. There are relations between these properties of elastic constant, which is used to find out the relation. We are using the symbol as word as the property as Poisson's ratio between the elastic constant, modulus of Young's modulus of elasticity and modulus of rigidity. We are having a equations E is equal to 2g plus 1, 2g into 1 plus mu, 1 plus mu. Okay, and similarly one more equation we are having, which is called as, for isotropic material, G is equal to E divided by 2 into 1 plus mu, 2 into 1 plus mu. Okay, let us discuss the problems of uh, any material just as are subject to a linear and lateral strain. What would be its Poisson's ratio? We need to check out this. Okay. Okay. I will read out the question. A copper wire is 2 meter long and 20 mm in diameter, which is subjected to a pull of 45 kilonewton. Copper wire 2 meter long, 20 mm in diameter, which is subjected to a pull of 45 kilonewton. Okay. What we need to find out? Find the change in length and diameter of the wire. If modulus of elasticity is 1 into 10 to the power of 5 Newton per millimeter square and m is equal to 4. Why they have given m? M is nothing but what? Poisson's ratio, which is relates with mu. Mu is equal to 1 by m. Please be remember the different sign convention used for the properties of material. Okay. Here the given that the wire having the length and diameter subjected to a pull means axial tensile force of 45 kilonewton. We need to find out the change in length and diameter of the wire. Okay. For any problem, you should read properly and establish the proper relations between the properties of materials. First of all, you have to write the data which is given the particular problem. What are the data given? D, diameter of the wire 20 mm diameter, and the length of the wire which is 2 meter, and also force which is given which is equal to 45,000 Newton or 45 kilonewton. 1 kilonewton is equal to 1000 Newton. So it is 45 kilonewton which is given. So obviously it becomes 45,000 Newtons. And mu is equal to what? 1 by m. What is mu? It is a Poisson's ratio. Indirectly they have given Poisson's ratio in terms of m. We need to find out that Poisson's ratio is equal to 1 by m, which is equal to 0.25, and E is given 1 into 10 to the power of 5 Newton per millimeter square. Okay. Next. So how to find out this? Okay. First of all, we need to find out area of this section. Okay. Area is equal to what? Pi d square by 4. Pi into d is 20 square divided by 4, which is equal to 314 mm square. You have to calculate it separately. Okay. Next, stress in the member. P by A. P is 45. Axial tensile force 45 into 10 to the power of 3 divided by A, which is equal to 143.3 Newton per mm square. Okay. We have established the relations for stress. Okay, what is called P by A, and find out the stress in the wire. And also we know that area of the wire, and also we know E, Young's modulus of elasticity, and also we know length of the wire. We can able to find out here change in length, which is equal to delta L, right? Correct? Or longitudinal strain, which is equal to, what is longitudinal strain? P by E. P by E, directly we can find out P by E. P is nothing but force 143, small p they have used that. E, stress by Young's modulus of elasticity. P is nothing but what? Yes, stress, small p, they have differently used their sign convention. 1 into 10 to the power of 5, which is equal to 0.00143. Okay, linear strain, we got it. Next, we know Poisson's ratio. The relation between Poisson's ratio and lateral and longitudinal strain is ratio of lateral strain to the longitudinal strain. Okay, it is denoted E lateral and E longitudinal strain. We know mu 0.25, that is Poisson's ratio, and we know longitudinal strain as 0.00143, and find out what is lateral strain. Okay, find out what is lateral strain. Okay, E lateral, that is a lateral strain, is equal to 0.25 into 0.0143. So E lateral is equal to 0.00035, and strain having no units because it's a dimensionless quantity. Okay, but actually in the problem they have asked to find out change in length divided by and change in length and change in diameter, right? Okay, we can establish the relation for that. We know longitudinal strain, and we know lateral strain, and we know axial length, and we know diameter, and easily we can able to find out what is the change in length and change in diameter. First we can find out change in length. Okay, longitudinal strain is equal to delta L by L. So delta L, change in length, is equal to longitudinal strain into length. So E is written here instead of E longitudinal. It represents longitudinal strain only whenever there is no subscripts. So you should remember that it is a longitudinal strain. Okay. Next, delta is equal to 0.00143, that is longitudinal strain, into 2000 because it's a 2 meter. So change in diameter, change in length is 2.8 mm. Similarly, E lateral strain is equal to change in diameter divided by original diameter. Okay, so change in diameter is equal to E lateral, it is nothing but lateral strain, into original diameter. So which is equal to, so E lateral strain is 0.00035 into original diameter 20, which is equal to 0.007 mm. They are not written the millimeter. Okay, this is what the delta phi, or it is change in diameter. This is about the problem which is related with the finding of lateral strain or change in diameter, or longitudinal strain or change in length, or Poisson's ratio. Okay, in the study material we have given sufficient problems. You go through that, and if you have any doubts, please uh, don't forget to get it clarified. Okay, thank you.